This talk is about effective brain-computer interfaces, and in particular about a specific phenomenon which is important in the technical development of such interfaces, and that manifests itself when subjects express anger. A quick reminder of the basics of BCIs. If you want to develop a brain-computer interfaces, essentially you need three things. You need to identify a target brain area, ideally associated with a cognitive process. You need to be able to capture a brain signal, ideally not too noisy and in real time. And you need the subjects to be able to have a cognitive strategy to activate that area. Now, that's easier said than done. Of course, for motor areas, which are under volitional control, that's not a major difficulty. But for effective brain-computer interfaces, there is a challenge. By nature, it's difficult to control your own emotions, and the entire user interface design is made more complex because of that. So generally, this is addressed by different aspects. One is to work on the cognitive strategies that subjects can use to express emotions, and the other is more with the interface paradigm itself. In particular, neurofeedback is a popular mechanism to make it possible for subjects to control areas of the brain that are normally not thought to be under volitional control. The ideal, but also a bit naive, method for developing effective BCI would be to try to locate a brain area in which a specific emotion is located. Unfortunately, current neuroscience thinking and knowledge tends to disprove that. There's a very good review by Lindquist, 2012, that quite convincingly suggests that there is no such thing as a localization of emotion. So if you move back prior to 2005, people thought that they would find fear in the amygdala, then it was arousal, and all that has since been disproved. Another option is to take an opposite strategy. Start with something which has a neuroanatomical substrate and look if it correlates with an effective dimension. And that happens to be the case with one of the, what more neuroanatomical there is than brain asymmetry. And if you take a specific area, which is the prefrontal cortex, there's been a lot of work dedicated to the asymmetry in the prefrontal cortex, much of that pioneered by Richard Davidson. So we have 20 years of research in prefrontal cortex asymmetry, and it's essentially correlated to one effective dimension, which is not much known or not much used in traditional effective computing work. And that dimension is approach avoidance, and sometimes it's called approach and withdrawal. It's a kind of very primitive Darwinian dimension. The interesting thing is that, as all dimension, it underpins more categorical emotions of higher level, and this one in particular is correlated to risk-taking as well as eagerness and even empathy, and of course anger, since it's the topic of the presentation. But the other interesting thing is that it is accessible to neurofeedback, and actually there's a lot of research, clinical research, using PFC asymmetry neurofeedback as an alternative non-drug-based therapy for depression. So let's have a look at what approach and avoidance would be. So this is an approach that's defined as an appetitive stimulus. Well, it's a bit early, but at least this kind of stimulus is non-controversial, fairly popular, maybe even cross-cultural. And you tend to be attracted by this stimulus. And there are stimuli where I don't have to tell you that you would find these repulsive, such as this one. But the prefrontal cortex controls us, but we also control the prefrontal cortex. And actually, the prefrontal cortex is an area of executive control. So approach and avoidance can be overruled. You can approach something that you don't like, and you can avoid something that you like. If I'm on a diet, I am going to withdraw from the pizza, even though normally it elicits approach. And about the scorpions, well, I can end up eating the scorpions instead of the pizza. So those things you have to do for science. Now, the interesting thing about anger turns out to be really important for the design of such interfaces. When I presented approach and avoidance, many of you thought that there's a big ambiguity with valence Is it not the case that a positive stimulus is always eliciting approach, or a negative stimulus is always eliciting withdrawal? Well, actually, in the case of anger, the very interesting phenomenon is that it's approach-related. When you're angry at someone, you're actually targeting that someone. So it's approach-related, but its valence is negative. And approach and valence are decorrelated. Hence, if you are able to build an anger-based BCI based on approach, you are sure that it's based on approach and there's no ambiguity with valence. And that's very important in the validation of that type of technology. So the method we use for signal acquisition is a functional near-infrared spectroscopy. So why do we do that? Because it's a metabolic method with a good spatial resolution, and in particular the dorsolateral prefrontal cortex, which is the area we're interested in, is easily accessible through fNIRS. There is a lot of previous work in fNIRS on emotional function, and it's also amenable to neurofeedback. And it should also be noted that there are neurofeedback studies with real-time fMRI, which is also a metabolic technique. And from these studies, we derive some inspiration for the methodology in this work. And if you are regular at UIST, which is not my case, you would have heard previous talks on fNIRS, which is also why I think we were attracted to submit here. We use a pretty standard commercial fNIRS system, which is the BioPack. It comes with, a small headband, which is frontal electrodes, and for us it's really perfect because we're only interested in a small part of the prefrontal cortex. And with these electrodes are actually called optodes because it's an optical method, and we're essentially interested in the top left and right optodes. What we're doing as a signal, we're mainly using HBO, and we're simply subtracting left activity and right activity. Now, this is the interesting part of the experiment. It's the real design of the neurofeedback BCI. So in this design, subjects will be asked to express anger at a virtual character. And this virtual character would have been introduced previously as being a bad guy, and we'll see that in a minute. And the principle of neurofeedback is that you're trying to activate certain specific functions. You've never done that before, so you don't know how to do it. So essentially, your brain activity is somehow wandering. If you're getting a feedback signal which confirms that you're activating in the right direction, then you're hooking up to whichever cognitive strategy you had at the moment. So neurofeedback is really an interesting method for subjects when they have to activate areas they did not think themselves capable of. And in this system, they will be resting, they're wearing the band with the optodes, they're also wearing a kind of, a cloth on top of it. This is just for ambient light reduction. And the system in real time will be measuring the prefrontal cortex asymmetry based on the real-time HBO values, and whether it crosses a threshold compared to a baseline activity. Of course, the feedback gives a visual signal, which is in that case the bad guy is disappearing. So if you're successfully expressing anger at the bad guy is disappearing. How do we know he's a bad guy? So we have a kind of narrative approach, and people are introduced to a short medical drama type of animation where there's a nice doctor, you see her here, and there's a bad guy who's a bully, and he has basically all possible evil traits you can imagine as misbehaving, and you get to really dislike him.
What do you think you're doing?
Pretty quickly.
Relax. I was just being friendly.
You do that again, and I report you.
Yeah, whatever. You should be a clever girl and let the real doctors do their work.
What are you talking about?
You better learn your place, or things will become more difficult for you.
So you clearly have here a compilation of every, evil trait in a colleague, and that gives also, it's a constructive approach to expressing anger. We try to refrain from, universal stimuli, and of course, there are ethical constraints on how you can get people to experience anger. It is particularly important for neurofeedback that the anger is targeted, and if ideally it's targeted at the visual component of the neurofeedback, then you get a very strong system. The problem with metabolic brain-computer interfaces is that you have no fixed baseline. If you were using EEG and prefrontal asymmetry with EEG, there's a fixed baseline, which is called an A2 value, which is a characteristic of every single subject. So you could calibrate with the subject and you're done. Everything which is metabolic is fluctuating. So what we're doing is that we're measuring the increase of asymmetry from a previous epoch, which is a neutral epoch in which subjects are looking at the evil character, but they are given a counting task. So they have cognitive load, but it's not effective. And that is used for measuring the baseline against which the symmetry score will be calculated. And as with all neurofeedback methods, you have something which is called a mapping. So the mapping is a decision of by how much you depart from the baseline and you move to the maximum threshold, which would give you the maximum feedback visual output. In that case, once you reach 100%, the bully disappears completely, and in between, there are different strategies to get visual neurofeedback, and opting for a linear strategy is generally an acceptable option if your signal variations are not too erratic, which is the case here. So what we're doing, you'll see the details in the paper, we're doing real-time statistical testing and a co-ND in real time to determine the mapping values. Now, summarizing a bit what I've just said through our UIST kind of official video, so this is the installation as it looks. Subjects, are wearing the optodes, and that's the measurement in real time. Simply, the right and left HBO activities and the real-time difference. And that's the video they're presented, after which they enter neurofeedback, and that's a real neurofeedback session where you see the bully disappearing when the subject is successful at expressing anger. So neurofeedback is something which is difficult and fluctuating. Here we have metabolic data which have low fluctuation, so it kind of dampens the oscillation and to some extent facilitates the neurofeedback task itself. Now, going to the results, this is a sample plot for one successful individual. What it shows is that the difference in activity is moderate during the calibration, the cognitive task, during which, even though he or she has been introduced to the character as a bully, by being given a counting task, they're not expressing any anger. And when they get to the neurofeedback phase, under the instruction of expressing their anger, you can see the difference in activity. And an interesting finding is that when you're measuring asymmetry between left and right, you have different components for a given asymmetry value. You could have, left going up, right going down, or only right going down. And what we have here in most cases is that it's an increase in left prefrontal cortex activity. If you plot the results through the system itself, you'll see during a neurofeedback epoch, you'll see the left part of the PFC flaring a bit. And the following result for our set of 11 subjects are pretty good considering state of the art in neurofeedback. We define success, so they go through 6 neurofeedback epochs. We define success in a way which is pretty standard in BCI work as subject being successful on half of these epochs. If you use that criterion, we have 73% of subjects who were successful. And if you just look across subjects at the individual neurofeedback blocks, 58% are successful. Now, if you look at the state of the art, that's state of the art or above. In particular, considering a very important aspect, normally neurofeedback requires training. You need 10 hours or more, depending on trials. And we did that with very minimal training. The reason why we didn't engage in extensive training with subjects is that there are ethical implications in changing possibly the asymmetry baseline, and we're not a clinical unit. So we've been erring on the safe side, which has not prevented us from getting interesting results. Now, there are many ways in the paper of analyzing the results and plotting them. One thing that is particularly interesting is the right-hand side of this plot, which really shows that during the cognitive load task, you really don't have any asymmetry, and then it goes up during the neurofeedback epoch task. This plot confirms that the asymmetry is primarily due to an increase in the left prefrontal cortex activity. And if you plot the entire population of subjects with their standard deviation, you really see a clear distinction between the neurofeedback left minus right activity and the calibration task. So I'm reaching the conclusions. What this study suggests is that fNIRS work for neurofeedback, but that has been established by others before us. But what is interesting is that it's possible to get prefrontal asymmetry via anger, so in a situation where clearly approach is decorrelated from valence. We had previous studies and ongoing studies on using empathy where approach is not decorrelated from valence, so it's important for the global validation of prefrontal cortex asymmetry as a BCI method that these results were obtained. So in further work we'll look at cognitive strategies that will try to relieve this ambiguity between approach and valence when valence is positive. And if you're interested in our line of work, in the ACM Digital Library you could find our augmented human paper on neurofeedback, and you can also find our ICME paper on empathy. Actually, ICME is this very same week, so I have a colleague presenting our paper there. Thank you very much.
Any questions? Okay, I have one question. So you only used one scenario in your study. I'm wondering whether there is a variety of ways for people to express their angers and whether there is a kind of taxonomy behind this.
You mean in terms of anger elicitation?
I mean whether there is more than one kind of way for people to experience and express their anger.
Well, in neurofeedback, actually, you're expressing it, and we don't know the level of anger experience, because this is not some, this is an emotional control situation. All work in emotional control, you are, especially when you're asking people either to arouse or to go from a resting state to an agitating state. So we had work, for instance, with colleagues in Tel Aviv on controlling the amygdala. This is a very unusual situation. If you have natural ecological anger and I'll suggest you calm down, you'll be calming down. But if you're smiling and I'll say, now you should get angry, that's a very difficult task. And that's what neurofeedback is about.
Okay.
Hi, I'm Erin Solove from Drexel University. Very nice work.
Nice to meet you, and we read all your papers with great interest.
Thank you. So I'm interested in this, and my question was actually related to what you were just talking about, which is, so you were asking people to elicit this anger. How well would this work if you were just trying to detect anger that's naturally occurring?
Well, you lose the neurofeedback aspect. That's the whole idea. There are two aspects. Experimentally, we're trying not to use the traditional frustration-based methods for anger, because we're not sure that the target will be part of the neurofeedback visual circuit.
Right, yeah, and actually my other question was related to, do you see other applications besides neurofeedback for if you're measuring anger?
Actually, this comes out of an application we've published in 2013 at ISHCAI, but was using EEG and fMRI. It's interactive storytelling, so the story that you've seen is actually an 8-minute virtual drama, and you can modify the course of the narrative if you express empathy with the nice doctor. And that has been published at ISHCAI, and the video is available on YouTube for an 8-minute video with fMRI data and EEG data. So we started with the application, and then as we got a bit more into the technique, we realized that there were some fundamental issues with the prefrontal asymmetry, and in particular this valence approach ambiguity, which could only be resolved by anger. And the reason why we moved to fNIRS is that we read your work, and we found that it was very well accepted for interfaces and very good for detecting the prefrontal cortex.
Okay, thank you.